In this video, we're going to tackle a challenging quadratic equation problem from the SAT. This problem was recently added to the College Board question bank, and I think many students may find it difficult at first. We are given three quadratic equations. The first equation is x squared plus 6x plus 7 equals 0 with the solutions r and s, where r is less than 7. The second equation is x squared plus 8x plus 8 equals 0 with the solutions t and u, where t is less than u. And third equation is x squared plus 14x plus c equals 0, where two solutions are r plus t and s plus u. Our goal is to find the value of c. Now, you could try to grab the first two equations in Desmos and find their x-intercepts. And we'll actually try that later. But first, let's understand the mathematics behind the problem. Before we jump into Desmos, let's recall Vieta's formulas. For quadratic equations, ax squared plus bx plus c equals 0 with the roots alpha and beta. The sum of roots alpha plus beta equals negative b over a. The product of roots alpha times beta equals c over a. Now, let's look at the third equation again. X squared plus 14x plus c equals 0. Its roots are r plus t and s plus u. Since the leading coefficient of the third equation is 1, Vieta's formula tells us that the product of these roots is simply c. So c equals r plus t times s plus u. That's the key idea. If we can find r, s, t, and u, then we can substitute them into this expression and find the c. Now, let's go back to the first two equations. They don't factor nicely, so we can use the quadratic formula. Remember, for ax squared plus bx plus c equals 0, the solutions are x equals negative b plus minus square root b squared minus 4ac over 2a. Of course, we could substitute the numbers and simplify all of these radicals by hand like this. But for this problem, we don't really need to do that. Instead, let's enter the quadratic formula directly into Desmos and let Desmos handle the arithmetic. For the first equation, x squared plus 6x plus 7 equals 0, we have a equals 1, b equals 6, and c equals 7. So for the smaller root, I'll enter r equals negative 6 minus square root 6 squared minus 4 times 7 divided by 2. And for the large root, s equals negative 6 plus square root 6 squared minus 4 times 7 divided by 2. I'm using capital letters R, S, T, and U in Desmos because the lowercase r is reserved for polar coordinates. Desmos displays decimal values for these roots, and that's perfectly fine. The important thing is that we enter the full quadratic formula expressions rather than copying rounded numbers from a graph. Now, let's do the same thing for x squared plus 8x plus 8 equals 0. Here, a equals 1, b equals 8, c equals 8. Since t is less than u, I'll enter t equals negative 8 minus square root a squared minus 4 times 8 divided by 2. And u equals negative 8 plus square root a squared minus 4 times 8 divided by 2. Now we have all four values stored in Desmos. Since c equals r plus t times s plus u in Desmos, all we need to enter is r plus t times s plus u. And Desmos gives us 31. That's our answer. So we found the answer without having to simplify all four radical expressions by hand. But now let's go back and try another approach. What if we use the graphs to get the roots directly? First, let's grab y equals x squared plus 6x plus 7. Now I'll click on the two x-intercepts. The left intercept is approximately negative 4.41. So I'll store that as r. And the right intercept is approximately negative 1.58. I'll store that as s. Now let's grab the second equation. Y equals x squared plus 8x plus 8. Again, I'll click on the two x-intercepts. The left intercept is approximately negative 6.82. I'll store that as t. And right intercept is approximately negative 1.17. So I'll store that as u. Now we can use the same expression from before, r plus t times s plus u. We get this value. That's extremely close to 31, but it's not exactly 31. Why is that? It's not because the graph is wrong. It's because the coordinates displayed on the graph have been rounded. Each root is a rational number, so its decimal representation continues. When we copy only a few decimal places and then perform another calculation with those rounded numbers, that small rounding errors carries into our final result. And this is an important decimal lesson. Graphing the equations is a perfectly reasonable way to find approximate roots. But if the problem requires an exact answer, you need to be careful about using rounded coordinates from the graph. For this problem, a better approach is first recognize the relationship using Vieta's formulas, then use the quadratic formulas to set up the roots. And instead of doing all of the radically arithmetic by hand, enter those expressions directly into Desmos. Desmos can handle the calculation for us. So you don't always have to choose between doing everything by hand and simply graphing. Sometimes the best approach is to understand the algebra first and then use Desmos to do heavy calculation. And this is a good example of how mathematical understanding and Desmos can work together on digital SAT. Thanks for watching, and I'll see you in the next SAT challenge.